Okay, hi guys. Today we are finishing up with electrostatics. So hopefully by the end of the day, you are able to define Coulomb's law, to define and explain electric field and electric field strength, and then apply the knowledge to questions. So yesterday we ended off, we had started the 2018 paper 1 question 7. And we got up to this question where they gave us this drawing and they told us that all three of these had the same charge of -3 × 10 to the -9 coulombs. They gave us the different directions. And then they asked us in question 7.4 to work out the net electrostatic force acting on P. So I had worked out my let me just find my whiteboard. Here we go. I had worked out the force of S on P, which was this one over here. And I found my answer to be 8.1 × 10 to the -6 newtons. And it was coming downwards. And then I had found the effect of T on P, which was 9 × 10 to the -7 newtons. And so we got up to that point, but now we need to work out the net force. So F net squared, and remember we're working with Pythag now. So you've got this, which is your Fy component. You're going to have this one, which is your Fx component. And then we are going to find the resultant force is equal to, so F S on P squared plus F T on P squared. And that gives me a value of F net. I'm just going to square root it from the start because then it's just easier to put it all into my calculator. 8.1 × 10 to the -6 squared plus 9 × 10 to the -7 squared. And if I put all of this into my calculator, my net force is equal to 8.15 × 10 to the -6 newtons. Okay, and so what is going to happen here is you've got P, so I'm just going to draw it here on the side. You have P over here, and it is having that force from T pushing it to the left-hand side. You're having the force from S pushing it down. So your net force is going to be between these two forces. And this is going to be your F net, or your resultant force. So it's going to be down and to the left. And they don't ask you for direction, they only ask you for the magnitude. So you can just leave it as that. You could explain that it is down and to the left if you wanted to. Okay, then question 7.5. They tell us to calculate the net electric field at the origin due to charges S and T. So they're basically asking you, what is the net electric field on P? So what we are going to use is the net force that we just worked out. So I'm just going to make a little bit of space. Okay. And so we're going to use this force over here and use the formula electric field is equal to force divided by point charge. Our point charge in this case is P. So we're going to use this 8.15 × 10 to the -6 newtons. And we are going to divide it by Q's charge, or the P's charge, which is this -3 × 10 to the -9, and you don't need to put the negative in there because the negative is just indicating where it's moving, and we've already figured that. So your electric field is equal to 2.72 times 10 to the 3 newtons per coulomb. Okay, so that's how you work out electric field strength. Then, so the trickiest part about these questions are actually just trying to figure out what they're asking you. Then question 7.6, they tell you one of the charge spheres, P and T, experience a very small increase in mass after it was charged initially. Which sphere, P or T, experienced this small increase in mass? Okay, so what you have to realize is you go back to the beginning, you go and look at what their charges were. So they went from having these charges to having the -3 times 10 to the -9 newtons, coulombs. So I'm going to work with sphere T and say that it gained electrons because it went from a positive 2 times 10 to the -9 coulombs to a -3 times 10 to the -9 coulombs. So if we were to show that, okay, it went from a positive 2 times 10 to the -9 coulombs to -3 times 10 to the -9 coulombs. So in order for that change to occur, it had to have gained -5 times 10 to the -9 coulombs. That makes the difference. So the formula that we then use is the number of electrons is equal to, oh, I might have jumped the gun. Okay, so that's how you know it's gained mass, because it's gained electrons, and electrons have a mass. Okay, so that answers the question, which one has gained the mass? Then they ask you to calculate the increase in mass by the sphere that you used in your previous question. So we now showed that it gained the mass because it gained that charge, which means it had to gain electrons for this charge to occur. So then we use the formula number of electrons is equal to charge over the charge of an electron. And this value is a constant. It is found inside your formula sheet. And my Q is this value over here that I just found by looking at the difference. So I'm going to say -5 times 10 to the -9 divided by, your electron always has a charge of -1.6 times 10 to the -19 coulombs. So they're both in the same unit, so they're just going to cancel out. And if you plot that into your formula, you get a value of 3.125 times 10 to the 10 electrons. So that's a lot of electrons. And I'm not rounding my answer to 2 decimal places yet, because now we just know how many electrons we have. Once we know how many electrons we have gained, oops, wrong one, we can go work out the mass by using the formula mass gain is equal to the number of electrons times the mass of an electron. And that would be equal to the answer that we just got, which is 3.125 times 10 to the 10. And the mass of your electron is also a constant found on your formula sheet, so don't stress about it, you don't have to memorize it. That is 9.11 times 10 to the -31 kilograms. So that is super small. And if I plot this into my calculator, I get a value of 2.8 5 times 10 to the negative 20 kilograms. And you can just say it's the mass gained. Okay, so does that make sense to everyone? The first thing that you had to go and do was you had to see what you had before they touched and what you have after they touched. So what is the difference between those values? Then you use the formula number of electrons is equal to the charge divided by the charge of an electron. That will give you the number of electrons that have been transferred. And then in order for you to get the mass, you will take those number of electrons just multiplied by the mass of an electron, and you will find the total mass gained by the system. Does that make sense to everyone? All understand how to work it out? Cool, thanks, Masayo. Okay, so that was question 7. Then November 2017, paper 1, also question 7. They tell you two small spheres, X and Y, carrying charges of plus 6 times 10 to the negative 6 coulombs and plus 8 times 10 to the negative 6 coulombs, respectively, are placed 0.2 meters apart in air. 7.1, state Coulomb's law in words. So Coulomb's law doesn't change. It's the magnitude of the electrostatic force exerted by one point charge on another point charge is directly proportional to the magnitude of charges and inversely proportional to the square of the distance between them. So this is one of those formulas that they literally ask in every paper that I have seen so far. Please go and memorize it. It is 2 points given, done and dusted. You don't have to stress about those 2 points. Then question 7.2, they tell you to calculate the magnitude of the electrostatic force experienced by a charged sphere X. So they're basically just asking you to work out the force for X. So if we go to, let me just copy that. You might need, no, I'm not going to copy. If we go to the whiteboard, sorry, we're just going to use the formula F is equal to Fe equal to K times Q1 Q2 over R squared. K is your constant, which is 9 times 10 to the 9. Your first charge was 6 times 10 to the negative 6. And my other one was 8 times 10 to the negative 6. And the distance between them was 0.2 meters. So we're going to square that. And if you plot this into your calculator, you should get a value of 10.8 newtons. Okay, so you literally just had to work out the force that is being exerted on X. Okay, it is a positive value, which means they are repelling each other because they're both positively charged. Then they tell us that a third sphere, Z, of unknown and negative charge is now placed at a distance of 0.3 meters below sphere Y in such a way that the line joining the charged spheres X and Y is perpendicular to the line joining the charged spheres Y and Z, as shown in the diagram. Then they ask us 7.3 to draw a vector diagram showing the direction of electrostatic force and the net force experienced by charged spheres Y due to the presence of charged spheres X and Z respectively. So what you would draw okay. Sorry. There you go. So what you're going to draw is your force between X and Y, because they're both positive, is they are repelling each other. So it's going to look like this. They're going to push each other away. So that is F of X and Y. Your force of Y and Z means your Y is going to be drawn towards your Z because they have opposite charges. So you'll have F, Z, and Y. So there's an attraction. So your overall force is going to come down this way. So it's going to move away from X to the right and down towards Z. That would be your overall direction. So this is the force diagram that you then draw. Okay. Does that make sense to everyone? Okay, cool. Then they ask us the magnitude of the net electrostatic force experienced by charged spheres Y is 15.2 newtons. Calculate the charge on sphere Z. Okay, so we are using our Pythagoras Theorem because you are still working with the same situation. So it's going to be that F net equal to Fx squared plus Fzy squared. They told us that our F net is 15.2. So you say 15.2 squared is equal to our Fx y squared, and we worked that out in the previous question, which was 10.8 squared plus your F and your Z on Y force squared. So then if I square these values and I subtract them from each other, I have a value of 114.4 is equal to F zy squared, and if I find the square root of both sides, I get F zy to equal 10.69579 ... So 10. You can round it to two decimal places. I'm not going to round it to decimal places because I know I need to use it in my next question. So I'm going to leave it as 10.696. But if you said 10.70 newtons, that would be correct. Okay, does that make sense to everyone? So the way to identify the direction of the wave vectors is you need to be able to tell yourself whether there's an attraction or a repulsion between the charges. So between X and Y, they are being repelled by each other. And we had to find it in terms of Y. So what happens to your Y sphere? It's been pushed away from X, so it's going to move to the right. And between Y and Z, your Z is going to pull your Y down because there's an attractive force between them. So it's going to go downwards. That's how you know the direction. So you have to know whether they are being attracted by each other or repelled by each other. Does that make sense, Msejo? Oh, I didn't finish my question. Sorry. So they were asking us to find out what is the charge on Z. So now you have your net force, so the force between your X and your Y, which means you can now use your normal formula. F ZY is equal to your constant times charge of Z, charge of Y over the distance between the two of them. So now you substitute this value that you got in there. 696. My constant is 9 times 10 to the 9. My QZ is what I'm trying to find. 8 times 10 to the negative 6 is the charge of Y. And the distance between them is this 0.3 squared. And if I plot all of that into my formula and take it to the other side, I find QZ to have a charge of 1.337 times 10 to the negative 5. And then you round that off to 2 decimal places because it's your final answer. So 1.34 times 10 to the negative 5. And always remember your unit, coulombs. Okay, so in order to find the charge that was on Z, we had to go and use our Pythag to find the force between Y and Z. Once we had that force, we could go and plot it into our formula and solve for X QZ, sorry, the charge of Z. Does that make sense to everyone? The steps you have to take to get there? Okay. So then in the question 8 of the 2017 paper, they tell us that you have A and B are two small spheres separated by a distance of 0.7 meters. Sphere A carries a charge of positive 1.5 times 10 to the negative 6 coulombs, and B carries a charge of negative 2 times 10 to the negative 6 coulombs. P is a point between sphere A and B and is 0.4 meters from sphere A, as shown in the diagram above. Then they ask us 8.1 to define an electric field at a point. So electric field at a point is a force per unit positive charge placed at that point. And the part that you get marks for is the per unit positive. If that's not in your definition, they don't give you the marks. So an electric field is a point where the force per unit positive charge is placed at that point. Okay. Then 8.2, they ask you to calculate the magnitude of the net electric field at point P. So let me just copy this. Going to take this to open a new one. OV. Just so that we see what our charges are. Oops. Okay, so we're going to use the formula. E is equal to K times Q over R squared. And we want to find the net electric field. So I'm going to say that I have an electric field coming from A. So this positive charge is exerting its positive electric field. If I had to draw the lines in there, are being exerted on P. And then you've got B, which is having its lines go inwards, but it's also exerting a force on P. So I'm going to work it out for A, and I'm going to work it out for B. So I'm going to say my net electric field is equal to my electric field from A on P plus my electric field from B. And then I'm just going to substitute this in there. So E Q of A over R squared plus K Q of B over R squared. So K is just 9 times 10 to the 9. My charge of A is 1.5 times 10 to the negative 6. And then my R squared is the 0.4 as shown in my diagram. Then for B, your K value is 9 times 10 to the 9. And my charge is 2 times 10 to the negative 6. You don't put the negative value in because it's irrelevant here. And why I'm saying that is the negative is only telling you the direction in which your object would move. But right now we're trying to see what is the electric field on P specifically. And that is the influence from both sides. So it's going to have to add, and they're going to be positive values from both sides. Otherwise, you'll end up subtracting. So don't put in your negative, only focus on your positive values. We're not worrying about direction now. That's going to come later. And the distance between P and B is the difference between 0.7 and 0.4. So that is 0.3. So 0.3, whoops, that is a 3 squared. Okay, and if I plot this into my calculator, I get a value of 48,375 plus, this gave me a value of 200,000. So if we add them together, it's 284,375. And then remember that you always have to try and write your values in scientific notation. So this will become 2.84 times 10 to the 5 newtons per coulomb. Okay, so does that make sense to everyone? We are looking at what is the electric field on P, and we have to look at what is it experiencing from A and what is it experiencing from B. So we add those two electric fields together, and we don't add in the negatives and the positives because we are just looking at the electric field that it is getting. What the charge is at the moment is irrelevant because charge is just indicating the direction in which it would move. Does that make sense? Everyone understand? Okay. So that was question 8.2. Then question 8.3, they ask us a point charge of magnitude 3 times 10 to the negative 9 coulombs is now placed at point P. Calculate the magnitude of the electrostatic force experienced by this charge. So I'm going to do it the quick way, which is you use the following formula. You use this formula. Fe is equal to QE. Okay, and we basically just use the formula E is equal to F divided by Q and we've just changed it around. Okay, so my point charge, they told me, had a value of 3 times 10 to the negative 9. And then my electric field, I just worked out in the previous question. So 2.84 times 10 to the 5. Just by the way, if you do get your previous question wrong, they do mark positively from there. So you won't get full marks because you don't get the correct final answer, but you'll get most of the workout marks because you've done the process correctly. So this gives you a value of 8.52 times 10 to the negative 4 newtons. Okay. You could have gone and worked it out the long way where you use the formula F net, or let's not say F net because you need to add them together. So F is equal to K times Q1 Q2 over R squared. And then you would have substituted your point charge into one of your Q's, and then each one of these would have been substituted in. So you would have found this for F of A, and then you would have done the exact same thing for F of B using this 3 times 10 to the negative 9 point charge. And then at the end, you would have added them together to get F net. So F net would be F of A plus F of B. But that's a really long way and you risk making mistakes. So the easiest way to just do it is use your formula. E is equal to force divided by point charge, and then use your force that you worked out in the previous question. Okay, the 2016 paper, also question 7. They tell you 7.1, in an experiment to verify the relationship between electrostatic force and distance between two identical positively charged spheres, the graph below was obtained. And then they show you the graph, and then they ask you to state Coulomb's law. We have stated it, so I am just literally going to copy and paste it. Please go and memorize this. I cannot emphasize how important it is. Okay, so it is just the direct proportionality between the magnitude of your forces divided by the square of the distance between them will give you the magnitude of your electrostatic force. Then question 7.1.2, they ask you to write down the dependent variable of the experiment. So always on the graph, your y-axis will be your dependent variable, the thing that you are looking for. So we would say that it is F E, and you could even just write the unit, even though you don't have to. So it is your electrostatic force. Okay, then they say what relationship between the electrostatic force Fe and the square of the distance R squared between charged spheres can be deduced from the graph. So if you look at that, you've got your Fe on your y-axis, you've got your 1 over R squared on your x-axis, and it makes a straight line. So whenever there's a straight line, it means there's a direct proportionality. But because your x-axis is 1 over something, it automatically tells you that it's an inverse proportionality. So you would write the electrostatic force is inversely proportional, proportional to the distance squared. And you could just use a formula to show that. So if E is inversely proportional to, 1 over r squared. Okay. Then question 7.1.4, they ask you to use the information in the graph to calculate the charge on each sphere. So I'm just going to copy this graph and take it to my whiteboard. And so I'm going to use the slope because slope is equal to FE divided by 1 over r squared. And 1 over r squared will just become your electrostatic force times r squared. Okay? And this, if you think about your formula, Fe is equal to K Q1 Q2 over r squared. And you take the r squared to the other side. Okay, then you've got K is equal to Q1, Q2. They told us that these two are identical. So you basically get K is equal to Q squared. So first we have to work out this value so that we can determine Q, because we're going to plot that into this. So what I'm going to say is my Fe r squared, which is my slope, is my y delta change in y over change in x. Okay, and I'm going to work with 0, 0 as one of my points, and I will work with 5.6 as one of my other points over here. And that gives me a rough idea of 0.027 minus 0 divided by 5.6 minus 0, which is equal to 4.82 times 10 to the negative 3 newtons meter squared. Okay, because it's force times r squared. Then you are going to take this value and I'll substitute it into this. So we're going to say 4.82 times 10 to the negative 3 is equal to K times Q squared. So 4.82 times 10 to the negative 3 is equal to K as a constant. So you substitute your constant value in there. And if you divide them, you get Q squared is equal to 5.355 repetitively times 10 to the negative 13. And if I put that into my calculator, I get a value of Q is equal to 7.32 times 10 to the negative 7 coulombs. And that's your final answer. Okay, so I know this looks like a lot. What you were supposed to realize is when they were taking you through the previous questions, that this graph was basically showing this formula, which is Fe is equal to K Q1 Q2 over r squared. From there, you can then go and try and work out what happens when I work out the slope of this. So like I did over here. And I got to the conclusion that it's my force times my distance squared. So what happens to this formula if you rearrange it? you get this. Then they told us in the briefing or in the question that your two Q charges, your two spheres, are identical. So here it is again, they tell you you've got two identical spheres. So what that means is this can just become Q squared. Okay, so then you go and you work out your slope, which we did over here using our graph. So they'll give you a range because the graph doesn't have exact points on specific lines or like here or whatever. So it's very difficult for you to see. So I'll give you a range for this. Then you take this answer and you set it equal to the formula. You substitute in your constant, which is k, that never changes. You do normal algebra, you square root it, and you find your final answer. Does that make sense to everyone? Do you understand where we got everything and where we were going with it? Yeah, awesome. Okay, so we are actually almost out of time. 7.2, they tell us a charged sphere A carries a charge of negative 0.75 microcoulombs, and they tell us draw a diagram to show how the field line surrounds sphere A. So because it's negatively charged, your field lines are going to go into your circle. Okay, so it's going to be negative and your field lines will go in. And then they tell you sphere A is placed 12 centimeters away from another charged sphere B along a straight line in a vacuum, as shown below. Sphere B carries a charge of 0.8 microcoulombs. Point P is located 9 centimeters to the right of sphere A. So what I'm going to do is I'm going to give this to you guys to try at home. As usual, this document will be uploaded onto the Google Drive and the answers will be there so you can check yourself. So quickly take a screenshot or just write it down, question 7.2.2, and go and try and work out your electric field. Okay. Tomorrow I am quickly gonna revise the work energy theorem that you guys did in the beginning of lockdown, and I'll work through some past paper questions like this, and I'll continue doing that on Thursday. So that's just a look at it again from maybe a different perspective than the way Ms. Vermeulen taught you guys, just to give some clarity because some kids were still unsure about how to use it. So please tune in tomorrow. And yeah, hopefully you guys are more sure about the work now. And my PowerPoints also have links on if you want to watch some videos, some more. This is grade 11 work, so I'm hoping that you guys feel comfortable with it now. See you guys tomorrow, same time, same place.